Hi everyone, we're looking at our next type of parallelogram, which is the rhombus. So let's take a look at this one. So specifically a rhombus is a parallelogram that specifically has 4 congruent sides. Now, a rhombus is a separate family outside of rectangles, because again, parallelograms can have 2 special groups inside them, one being the rectangle, the other one being the rhombus, which we're about to look at now. So when we take a look at their properties, all right, since a rhombus is a parallelogram, it's going to have all the parallelogram properties here going on inside that figure, meaning your opposite sides will still be parallel and congruent, and opposite angles will still be congruent. Consecutive angles, meaning on the same side, will still add up to 180. All of that is going to work here for the rhombus. Now, more specifically, a rhombus does have some other things going on with it. One of those properties that happens in the rhombus is that the diagonals will be perpendicular. And remember, that just means they're going to measure 90 degrees. That's what perpendicular means. The other thing is that those same diagonals are going to bisect. And remember, bisect just means cut in half those opposite angles. Okay, so those are our main properties. So again, all the properties with parallelograms are going to be going on, plus our additional ones here about the diagonals. So let's see how all of this starts to look for our rhombus. So first off, let's just take a quick look at some drawings for rhombus. So whoops, sorry, I'm going to make that a little bit smaller. All right, so since it is, again, a parallelogram, your opposite sides will be parallel. And same for the other 2 sets of sides. And those sides are going to be the same length all the way around. They're all 4 congruent. So that is what makes this specifically a rhombus instead of just a parallelogram. Now, looking at those diagonals, okay, it says that your diagonals are perpendicular. So these 2 diagonals will make a 90-degree angle where they intersect. Now, also because of the fact that it's a parallelogram, those diagonals will be bisecting each other, but it is not a rectangle, so those lengths are not equal. And the other thing is the diagonals here will bisect the opposite angles. So the opposite angles from parallelogram that would be congruent are split in half by the diagonals. So all of those little slices there, those little angle pieces are going to be congruent. So let's see what happens when we start looking at some examples. So example 1. Find the value of x in the figure below. All right, so x is a side length, And like we said earlier, all 4 of these sides in a rhombus are exactly the same length. So if one of them is 15, they're all 15. And so there's my x. All right, let's try example 2. This time the x is up in that angle D section, but it's only that one piece. So only this part is where the x is sitting. So one thing it tells me that, again, I know with diagonals, all of these right here where they intersect are 90. It also tells me that the measure of angle ABC is equal to 80. So remember, measure of angle ABC. So we're going to start where A is, go down to B, and out to C. That whole thing is what is 80 degrees. And remember, that diagonal splits that in half. Now, if we were to take those diagonals out of there, remember, because it's a parallelogram, opposite angles are congruent. So if this bottom angle is 80, so is the top angle. But again, that line, that segment inside that shape splits that measure in half. So for us to get this x, we're going to have to divide that 80 by 2 because x is only half of that. So then my x needs to be 40 degrees. Okay, let's check out example 3. Find the value of x and y in this rhombus. All right, so again, definition of rhombus, all the sides are exactly the same. So if one of those sides is 13, so is the other. So are the rest. So I know that much now. Other things I know about a rhombus, where the diagonals intersect, they're all 90 degrees, and that 3x is sitting inside of one of those 90s. So right away, I know 3x is supposed to be 90. Let's solve this for x. Divide out that 3, and my x right now is 30 degrees. Now let's check out y. Y is not an angle measure. It does not have a degree bubble. It is that one specific piece of the diagonal. Now, I don't know what's on the other side, or else I could get the whole entire way. I don't know either of those. So I don't have a value that I can cut in half to get that y number. But one thing I do have, I know that since there is a 90 degrees in the middle of this rhombus, I have a right triangle here, and we looked at different ways you can solve for a missing piece of a right triangle of a side. We have 2 out of the 3 sides of this triangle. I have the short side of 5, the longer side, which is where the y is, and like our other right triangles, across from a 90 is a hypotenuse. I can use Pythagorean theorem. So the y that I need, again, I'm going to call that my b side. So I want the formula that says b equals the square root of c squared minus a squared that we learned last unit. So y equals the square root of 13 squared minus 5 squared. Okay, so y equals the square root of 169 minus 25, which is the square root of 144. And so my y is equal to 12, because that is a perfect square there. So now we have both our values. So sometimes we might need to use Pythagorean theorem. So keep all those formulas in mind that we've worked with. Let's check out our last example, example 4. All right, so because this figure, again, is a parallelogram, opposite angles are still going to be equal to each other. So then 100 should still equal x plus 75. And now we can solve this. So I'm going to minus my 75 to both sides of this equation. So I'm going to make that just a little bit bigger. And so 25 is equal to my x. And that's it. There's nothing more to solve there. Okay, guys, I hope you enjoyed learning a little bit about the rhombus. But again, remember, every property that we did with parallelograms is going to go on here as well, like this one we just saw in example 4. So please don't hesitate to reach out to me if you have any questions at all.